Hello, my dear students of Production Engineering Department, NIT Agartala. I hope you all are well. We all are staying at home due to COVID-19. The whole world is fighting against that deadly virus. So, before starting my video lecture, I want to request you to stay at home, take care of yourself as well as your family members, and also of the whole nation, and pray to the Almighty God to save the world from this coronavirus. So, we all know that lockdown is going on, so don't cross the boundary of your house and invite the deadly virus. Take all the safety precautions like wearing mask, hand gloves, wash your hand with soap or liquid soap, take healthy foods which will improve your immunity system. Try to drink 1 glass of milk with turmeric powder at night. Inhale vapor twice a day. You can add some turmeric powder and ginger powder in that water. Also take vitamin C rich foods. You also can take Chyawanprash at morning and drink herbal tea. Stay safe, stay healthy, and stay at home. I also want to suggest you to download Arogya Setu app and help India to win the fight against the deadly virus, coronavirus, and COVID-19. Now, I shall start my lecture of the subject engineering materials. And our today's topic is binary diagram. So first of all, what is binary diagram? Binary diagram is that type of diagram which is having two components in it. So what is component? I have already discussed in my previous classes, and the difference between phase, component, composition and all. I think you all know about that components, phase and composition. So now, a binary phase diagram is a temperature composition map which indicates the equilibrium phases present at a given temperature and composition. Now you can ask me, what is equilibrium state? That that part I have already discussed by drawing some blocks in your classes, like most stable equilibrium, which is Fe2O3 and Al2O3 CuSO4, and metastable equilibrium, which is Fe, Cu, Al, etc. I also discussed about that stability criteria, which depends on free energy, not on internal energy, not even on entropy. And from these, I also talked about three types of energy, free energies: thermodynamic free energy, Helmholtz free energy, and Gibbs free energy. So, this equilibrium state can be found from Gibbs free energy, which depends on temperature and composition. Now, what are the different variables in binary diagram? First of all, there is a composition variable, and we have two thermodynamic variables. We already talked about that thermodynamic variables. We have two types of thermodynamic variables, and you all know that these two thermodynamic variables, these are pressure and temperature. We have to represent these variables on a two-dimensional diagram, which may be a plane or a paper or a blackboard. So these are all two-dimensional surfaces. First of all, we shall discuss about composition variable. You can see one diagram to know about this composition variable. So we are talking about binary phase diagram or binary diagram. So what are the different axes? Okay, first of all, the first variable is composition variable, and we will talk about this composition variable. So as we are talking about binary phase diagram, binary which is consists of two components. So here in composition there will be two components. In this side, left hand side, that is A component, and right hand side it is B component. So whenever we will go from left side to right side, that means here at the left side A is 100% and B is 0%, and at that extreme right side B is 100%, A is 0%. So from left to right, from this left to right, B is increasing and A is decreasing. And here I am talking about that percentages. These are weight percentage, not atomic percentage. These are all weight percentage. Okay, and we can show that weight percent as W oblique O, weight percent. If it was weight percent, then we have to write as A oblique O. Okay. So we have two components here. One is A, another is B. From left hand side to right hand side, B is increasing, and from right hand side to left hand side, A is increasing. So this is one composition, and we have a composition variable for every phase. That what I can count it as P into C minus 1. So I think you all have seen this formula in my previous classes. P into C minus 1. P is phase, C is component. And why it is minus 1, I have already discussed in my previous classes. Those who have attended, you all maybe know that why it is C minus 1. For composition, for composition, this will be C minus 1. C means components, P means phase. Okay. Composition of phase 1 may be differ from composition of phase 2. Also may be differ from phase 3 and so on. In unary diagram, the composition of all phases are same as there is only one component. Okay. I have already discussed about unary diagram in the last class. Okay, and in unary diagram, the number of component is 1. So as there is only one component, also we can say the number of phase for that component will be 1. So in this diagram, composition diagram, let us say we have two phases. One is alpha phase another is beta phase. Here it is alpha phase and here it is beta phase. So what is alpha phase and what is beta phase? Alpha phase, which is consists of 0 to 30% of A, 0 to 30% of that B, as B is in the left hand side, B is 0% and A is 100%. So from that left hand side to that point, it is 30% of, and obviously it is weight percentage, 30% of B. Okay, so from 0% of B to 30% of B, it is alpha phase, and from 80% of B to 100% of B, it is called beta phase. Okay, the remaining percentage is of A, about this one, alpha and beta. Okay, so here we have two phases, one is alpha and another is beta. Alpha is having 0 to 30% of B and beta is having 80 to 100% of B. So here in this place where 0 to 30% of B, alpha is in equilibrium state. Okay, so as alpha is in equilibrium state, there is no beta phase will be available in this place. Okay, and from 80% of B to 100% of B, that is beta phase, and this beta phase is equilibrium in this region, and as this beta phase is in equilibrium in this region, so alpha phase is not available in this place, only beta is there, and in between these two phases, alpha and beta both are available, alpha plus beta, from this to this place. Okay, so here we can find alpha and beta or combination of alpha beta, where alpha and beta both are not in equilibrium. Okay, and here as it is alpha phase, means alpha is in equilibrium, so no beta phase is there, and here beta is in equilibrium, so no alpha phase is there. So from here, one question may appear in your mind that for different phases, should we take different axes for one phase, one axis, two phase, two axis, three phase, three axis? No, not required. We can show all the phases in one axis only. So here you can see we have two different phases, and we are showing these two different phases in one axis. Okay, so we can show different phases in only one axis. So there is no any requirement of any other axis to show different types of different phases in a equilibrium diagram. I am again repeating this thing. So here alpha is in equilibrium, means from 0 to 30% of B, in this place beta is not present. Similarly, where beta is in equilibrium, alpha is not there. In between 30 to 80% of B, both alpha and beta phases are present. So it is possible for us to represent the equilibrium between more than one phase on a same axis at a given temperature and pressure. This axis is called composition axis. This axis is called composition axis. And the component should be written alphabetically from that left side to right side. So we have to write all the components. If we have 2 components or 3 components or more than 3 components, we have to write these in alphabetical order from left side to right side. Let us say, for example, we have silver and copper. Silver is Ag and copper is Cu. So Ag will be in this side and Cu will be this side. Ag A, so that is in left side. Cu C, that is in left side. So if we have copper and nickel, then we have to write copper in this side and nickel in this side. So in case of that composition axis, we have to write all the components in alphabetic order from left side to right side. Then we have 2 thermodynamic variables. One is pressure and another is temperature. Here pressure can vary from 0 to infinity. Pressure cannot be negative. Pressure is from 0 to infinity. That's why this pressure variable is, or pressure axis is, semi-infinite axis. Also we can say for temperature, it can vary from 0 Kelvin to infinity. So we have one composition axis which is finite axis and one pressure axis this is semi-infinite axis. Okay, why it is semi-infinite? Because pressure can vary from 0 to infinity, not from minus infinity to plus infinity. If it is minus infinity to plus infinity, then we can say infinite axis. Okay, or from 0 to 100 pressure, 100 atmospheric pressure, then it is finite axis. But in case of pressure, it will vary from 0 to infinity. That's why it is semi-infinite axis. Also, if we take temperature, this is also one semi-infinite axis, as this temperature also varies from 0 Kelvin to infinity. So we have 3 axes for binary diagram. One is composition, which is finite axis. One is pressure. These two are thermodynamic variable. Okay, so these thermodynamic variables, 2 thermodynamic variables are, these two are semi-infinite axis, as these are varies from 0 to infinity. So now we have one finite axis and 2 semi-finite axis. Finite axis is composition axis and semi-infinite axes are this pressure and temperature axis. Means 3 axes we have, and for these 3 axes we have to go for 3-dimensional diagram, as there is 3 axes, x-axis, y-axis and z-axis, 3 axes. So we have to go for 3-dimensional diagram. This 3-dimensional diagram we cannot draw in a paper or in a blackboard or any kind of plane, as these plane are having only 2 dimensions. So what we can do, we can take a substitute of this 3-dimensional diagram. We can take a section of this 3-dimensional diagram. Okay, so we shall take that section of this 3-dimensional diagram. We can take this section either on a constant pressure or a constant temperature. So we have to fix one thermodynamic variable as constant. So when we take constant pressure, it will be known as isobaric process, and if temperature is constant, then it is known as isothermal process. This I also already tell you about this isobaric and isothermal in my previous subject, that was engineering thermodynamics. So I think you know about isobaric process or isobaric diagram and isothermal diagram. Now we have to fix one variable, and the most comfortable variable which we can fix is one of the thermodynamic variables, either pressure or temperature. Now we are having one semi-infinite axis, one finite axis, as we already fix one of the thermodynamic variable as constant. Most of the systems where engineers are working is at 1 atmospheric pressure. Temperature can vary. Temperature can vary from 0 Kelvin to 1000, 2000, 3000 or 10,000 Kelvin. But most of the cases we are taking that pressure as 1 atmospheric pressure. So we shall take the pressure as constant pressure and take the diagram as isobaric diagram by fixing this pressure as constant. So we make the exercise 1 degree of freedom by choosing one variable, that is pressure, as 1 atmospheric pressure. Now our phase rule we have already talked about phase rule. This phase rule I have discussed in your previous classes. Now I will modify this phase rule, and that new phase rule is known as modified phase rule. So I think you can remember that phase rule, which was F plus P is equal to C plus 2. That was the phase rule we have already discussed in your classes. So what is 2 in this phase rule? This 2 is for those thermodynamic variables, pressure and temperature. 2 is for that thermodynamic variable. One is pressure and another is temperature. But right now we have converted these two into one by fixing that pressure at 1 atmospheric pressure. So now we can rewrite this phase rule as F plus P is equal to C plus 1, as pressure is not there, or pressure is constant in this case. So this new phase rule is known as modified phase rule. Okay. Here 1 is for temperature, not for that pressure. So previously you have studied about that phase rule, which was F plus P is equal to C plus 2. 2 is for pressure and temperature, in this case two variables are there, pressure and temperature, both are variable, but now pressure is constant, that's why this 2 becomes 1, because we exercised 1 degree of freedom. Okay, so we have talked about this binary diagram, and right now that modified phase rule, which is F plus P is equal to C plus 1.